4.3, using studies wisely. So now that we know how to take samples and do surveys and experiments, we got to make sure that the conclusions that we come up with are valid and make sense. Okay, so what can we infer from our studies or experiments? All right, if we took a random sample of a population, then we can take our conclusion of our study and infer that that applies to the whole population, okay? Because the members were randomly selected, we can kind of say, yeah, that makes sense, all right? But we need to be aware that whatever data we get from a sample, while it may be close, it's probably not going to be exactly like the population data. So if that is a concept called sampling variability, which means each sample that we take from a population is going to be slightly different than the actual population value. Like if we're looking at mean height, okay, each sample is going to have a mean height that's slightly different than the population as a whole. Okay, ways that we can decrease sampling variability is to increase sample size. All right, the larger sample size, the less we're affected by outliers. So they are going to be closer to that true value, the population parameter. Okay, so we have a sample of 50 NFL players. Their average weight is 244.4 pounds. If we weighed every single player in the NFL, would their average weight be 244.4? Probably not, okay? It would be somewhere close, all right, but it's probably not going to be exactly 244.4. Which would be more likely to give an estimate closer to the true average weight of all NFL players? Random sample of 50 or a random sample of 100? All right, that's what we just talked about, random sample of 100. The larger our sample is, the closer we're going to get to the true population value. Okay. Then when we do experiments, okay, remember we said that we could use experiments to look at cause and effect. All right, the key is, okay, we're trying to decide whether it is one of these two things. Either the difference was just random, okay, so if I gave one group some medicine and another group not, is the difference in their disease after, did it just happen because chance? Or did my medicine that I gave them actually cause the difference between the two groups? Okay, when our results, we can say, are too unusual, and we'll define exactly what too unusual is later in the year. But if we have results that are too unusual to be explained by chance, we call those results statistically significant. Okay, so it's kind of like what we talked about day one, where we expected 3 female pilots and we ended up with 5, but we said that difference wasn't large enough to be called statistically significant. It could happen just by chance. Okay, so if we have random selection, meaning we're randomly finding our sample, then that means we can take our inference to the population, the whole population from which we chose those people. If in an experiment we have random assignment, that's the way we can do cause and effect. Okay, so we randomly assign people to the treatments in our experiment, and that is how we can infer cause and effect. Okay, so we got a little chart here to sum it up. All right, did we have randomly selected individuals, and were they randomly assigned to groups? Up here, this yes rarely happens, because we can't usually randomly select people and then force them to take part in an experiment. Okay, so typically we can have, if we have yes on randomly selected, we usually have no, or no on randomly assigned to groups, because we can't force people to take part in an experiment. And same thing, if we have yes on randomly assigned to groups, we typically have no on randomly selected. Okay. But they like to ask questions like, they'll explain a study and say, can we infer that these results apply to the whole population, or can we infer cause and effect? All right, so they like to ask you those questions, so just make sure you understand basically these two facts. Random selection means we can apply it to the whole population, and then random assignment means we can prove cause and effect. Okay, that's it.